This isn't a geometry class, but there are some things that we're going to expect that you know about some basic shapes. We'll discuss a few of these ideas here, and then we'll look into them in more detail in later lectures. Let me start by drawing a rectangle. One of the things that distinguishes a rectangle from other shapes is that its sides, its opposite sides, are equal in length, and all four corners are nice, tidy right angles, 90-degree angles. We talk about the length of a rectangle and the width of a rectangle. But mathematicians, being notoriously lazy, tend to abbreviate everything. We'll usually just call the length L and the width W. Some textbooks tend to use capital letters L and W when we're talking about geometric shapes. It's fine to talk about the length and the width of a rectangle in general, but we usually have actual numbers associated with these. Let's say that this rectangle has a width of 3 and a length of 5. When we're discussing the perimeter of a rectangle, what we mean is how far is it all the way around the outside of the rectangle. Since its opposite sides are the same length, we can find this perimeter by first labeling, at least mentally, the missing lengths, and then starting in one corner, measure how far it is from one corner to the next, and add that to the next length, add the next side, and then add the last side. The total length is 3 plus 5 plus 3 plus 5. So the perimeter of this rectangle is 3 plus 5 plus 3 plus 5. 3 plus 5 is 8. 3 plus 5 is 8. And 8 plus 8 is 16. Since what I'm doing here is adding up the lengths of the sides, I could actually add them in any order. What happens if I add the two shorter sides together first, and then add the two longer sides? That gives me 6 plus 10, and 6 plus 10 is still 16. Let's try this with a different rectangle. What if this rectangle had sides of length 21 and length 46? The perimeter of this rectangle would be 21 plus 46 plus 21 plus 46. 21 plus 46 is 67. 21 plus 46 is 67. Add those two together and I get 134. So the perimeter of this rectangle is 134. What happens if I add the two short sides, the two widths together first? 21 plus 21, this width and this width. And then afterwards, add the 46 and the 46. 21 plus 21 is 42, and 46 plus 46 is 92. Add those two together, and we still get 134. So again, I can add in any order. Why is that important? Well, what if I didn't know the lengths of the sides of my rectangle? What if all I knew about them was that they had a width W and a length L? Could I find the perimeter of this rectangle? Sure, although only in general terms. The perimeter of this rectangle is W plus L plus W plus L. Since it doesn't matter what order I add these in, I could think of it as W plus W plus L plus L. And W plus W is 2W. And L plus L is 2L. And then I would add these two together. Mathematicians tend to be a fairly lazy lot. Just like we chose to use W instead of writing out the word width, I'm going to use the letter P instead of writing out the word perimeter. If I write P for perimeter equals 2 times the width plus 2 times the length, this is what we call a formula for the perimeter of a rectangle. It's a formula because I don't actually know the width and the length. If I did, I could just put those values in place of the L and the W, and I would get my answer for the perimeter of the particular rectangle whose length and width I knew. Let's test this out. Let's see if we can find the perimeter of a rectangle whose length is 10 and whose width is 6. Doing it the old-fashioned way, we would say that the perimeter was 10 plus 6 plus 10 plus 6. That's going to give us 16 plus 16, which is 32. Doing it the old way, my perimeter is 32. Doing it the new way, since I know the width of the rectangle and I know the length of the rectangle, I can replace the letter W with what it represents, the 6, the width for this particular rectangle. And I can replace the letter L with what it represents, the 10, the length for this rectangle. Using order of operations, I have 2 times 6 is 12, and 2 times 10 is 20, before I add them together. When I do add them together, 12 plus 20 is 32. So my perimeter is 32. Regardless of which way we do it, we ended up with the same perimeter, 32. Another observation to make here is that lengths of sides of rectangles are usually either inches, or feet, or miles, or centimeters. If they're in inches, then let's face it, they're all going to be in inches. If they're in miles, all 4 sides will be measured in miles. But when I take the perimeter as the distance around the outside of the rectangle, it's as though I'm walking 10 inches, 6 more inches, another 10 inches, and an additional 6 inches. So I will have walked a total of 32 inches. That's why when we use the formula for the perimeter of a rectangle, I still have to make sure to include the label that's appropriate to the problem that I'm working with. A square is really just a special rectangle. Watch what happens if I take this rectangle and bring it in so that all 4 sides are the same length. I used to call this L for length and this W for width. But they're the same length now, so shouldn't I use the same letter? Instead of L for length and W for width, let's use L for length for all 4 sides. It actually doesn't matter what letter you use, and your textbook likes to make a special case. Since a square is a very special case of a rectangle, instead of saying L for all 4 sides, it uses the letter S. I'll follow that practice here as well, just so that your notes from these videos match what's in your textbook when you go back to look at them later. If a square has sides 3 inches, then all 4 sides are 3 inches. So when I go to look for the perimeter of the square, I need to add the 3 plus 3 plus 3 plus 3. The perimeter of this square is 3 plus 3 plus 3 plus 3. 6 plus 6, which is 12. Since a square is just a special rectangle, we could also have done this by using the formula for the perimeter of a rectangle. What I have to be careful about is the fact that the width and the length are the same numbers. Since the width and the length are both 3 for this particular square, my formula would look like this. Again, using the order of operations and doing multiplication, before addition, I get a perimeter of 12. That's the perimeter of the square, and that's the same number as I got by doing it the other way. If I want the formula for the perimeter of a square, since I'm using S for the length of the rectangle and the width, I can replace the W in my formula for perimeter of a rectangle with S, and I can also replace the L with S. L and W are both S if the rectangle I'm playing with happens to be a square. Here I'm saying I have S 2 times, and here I have S 2 times. So really, I have S 4 times. And this is the formula for the perimeter of a square. Keep in mind that a square is just a special case of a rectangle, and you don't really need to memorize a second formula. You can always use the formula for the perimeter of a rectangle, even if you're working with a square. Whether you're working with a rectangle or a square, the lengths of its sides are measured in feet or miles, yards or centimeters. Whatever one side is measured in, the other sides will be measured in the same unit. Here's a square with sides of 4 yards each. If I walk around the outside of this square, I will have walked 4 times the length of the side. In this case, that's 4 times 4 yards. So the perimeter of this square is 16. When you're dealing with perimeter, the label in your answer is the same as the label given for the length of the side. Let's talk about a triangle. There's no formula per se for the perimeter of a triangle. It's just the length of the first side plus the length of the second side plus the length of the third side. And with an exception of a very special case, it doesn't really matter what you call each side. Here's a triangle with sides A, B, and C. But A, B, and C have to be numbers. It looks like we might have 2, 3, and 5 for the lengths of the sides of this triangle. Perimeter in this case is just 3 plus 5 plus 2. Again, that can be in any order. We'll talk about that more in another video. 3 plus 5 is 8. If I add 2 to that, I get 10. The perimeter of this triangle is 10. But 10 what? Was it measured in centimeters, or feet, miles, or kilometers? Whatever the lengths of the sides of the triangle, or the square, or the rectangle, whatever unit is used to measure the lengths of the sides is the same as the unit used in the answer, since you're simply looking at the total of the lengths of all of the sides, regardless of the shape of the figure that you're actually working with. Before we go on, I'd like to summarize. The formulas we've learned so far are the perimeter of a rectangle is 2 times its longest side plus 2 times its shortest side, or 2 times its length plus 2 times its width. The perimeter of a square is found by multiplying the length of its side by 4, since all 4 sides are the same length. For a triangle, the perimeter can only be found by adding together the lengths of the 3 sides.